Hello, this video presentation is on factoring using the quadratic form and a little bit more just in general factoring called basically factoring completely. All right, what we're going to be doing is looking at factoring polynomials that look exactly like we've always done. Here we have an x to the fourth and x squared. Instead of factoring something with x and x, we're going to factor with x squared and x squared. Because x squared times x squared is x to the fourth. And when we do the double smiley, we'll have x squared. So the work is exactly the same. No difference at all. None whatsoever. First thing, greatest common factor. 5 times 9x to the fourth plus 36x squared plus 32. And then we're going to do our parentheses like always. But instead of x and x, we have an x squared and an x squared. All right? Now, just like always, we look for our factor pairs. 9 and 1, 3 and 3, 32 and 1, 16 and 2, 8 and 4, and that's all there is. I'm going to try 3 and 3, 3x squared and 3x squared, plus and plus, all right? And then we'll try 8 and 4. Looks like it might work. And when I do my double smiley, 12 and 24 is 36. We're good to go. All right? Always check that double smiley. All right. Now, the last thing, and we are actually done with this problem, but the last thing is always look and see if there's anything else you can do. That comes under the factoring completely. And a lot of the problems we're going to do, you're going to find you have to go one more step because it's not completely factored. All right, let's look at the next one. Here we have a 19, so there's no common factor. So we're going to immediately look at this. And we're going to have something x squared, and we're going to have a minus here and a plus here. It's going to have to be minus and minus. So we have 12 and 1, 6 and 2, 4 and 3, 4, 4 and 1, and 2 and 2. Pretty basic. I'm going to try 4 and 3, 4x squared and 3x squared. And I'm going to try 4 and 1. I can't put the 4 here because then I'd have a common factor, and there is no common factor. But I can put the 4 here and the 1 here. And then I do my double smiley. -3, -16 is -19. That is really a poor 9. And we find out that it works. -16 and -3, -19, good to go. Now, normally we would consider ourselves done. But we have to look and ask ourselves, can I factor this? Nope. Can I factor this? Yes, I can. Perfect square, perfect square. We can factor that 2x minus 1, 2x plus 1, and then we have 3x squared minus 4. You will not always be able to factor one more time, but you need to always check. All right, here's one that looks a little bit different because we have an x to the sixth, and an x to the third. But just like the other ones, because the 6 is double the 3 and the 6 is even, I can go with x cubed and x cubed. But first of all, let's get our common factor out, which is 2. X to the sixth, coefficient of 1, that makes it easy, minus 11x cubed plus 24. And then, instead of x squared and x squared, like the last examples, we're going to have x to the third x to the third and x to the third. We have a minus here, plus here. It's going to have to be minus and minus. Now, I need factors of 24. I'm going to try 8 and 3. My double smiley, negative 8, negative 3 is negative 11. We're good to go. And now we have to check, can I factor any further? Well, x cubed minus 8 is the difference of perfect cubes. We had a formula. X cubed minus y cubed was x minus y, and x squared plus xy plus y squared. All right, so here we're going to use x and 2 instead of x and y. We have x minus 2, and then the quantity x squared plus 2x plus 4, and then we have x cubed minus 3. All right, don't forget, it's easy to do, don't forget that this is part of our answer. All right, so always look, could be the difference of squares, could be the difference or sum of cubes, you never know. All right, we have one more example that we'll do with factoring by grouping. Here we have 4 terms. When we had 4 terms, we always used factoring by grouping. It was the last thing we learned. So we group these together and we look for common factors. Here I have an x cubed, and so it's x squared plus 4, minus, so I have a minus 8 x squared, and this is where people made mistakes before. It's plus 4. Why plus? Negative times positive is negative. And then we see x squared plus 4 is a common factor. So we bring that common factor out, x squared plus 4, and we're left out here with what's left, x cubed and a minus 8. And then we look, can we factor? Well, x squared plus 4, sum of squares, you can't factor that, not in the real numbers. And x cubed minus 8, just like the previous example, difference of perfect cubes, x minus 2, x squared plus 2x plus 4. And we're done. That's it. Hope this made sense. It's really nothing new, just kind of an extension of what we did before. So we'll talk to you later. Have a great day and keep on keeping on.